Very welcome to the chemistry by melaghumakra, and today's topic is nuclear fusion. Nuclear fusion, the process of fusing or combining together two or more like nuclei to form a heavy nucleus with release of tremendous amount of energy, is called nuclear fusion. In all fusion process, the total mass in the reacting atom is greater than the mass of the product nucleus, and this difference in masses results in the release of energy. According to Einstein equation, E equals to m into c square. For example, consider a single helium nucleus formed by the fusion of two deuterium nuclei. Here mass of 1 sub 1 H sub 2 equals to 2.01478 AME, and mass of helium, that is He sub 2 sub 4, equals to 4.00388 AME. Now the reaction is H sub 1 sub 2 plus H sub 1 2 fusion equals to fusion tends to He sub 2 sub 4. Hence, initial mass of two deuterium atom 2 into 2.01478 equals to 4.02956 AME. Mass of helium atom 4.00388 AME. Hence, decrease in mass 4.02956 minus 4.00388 equals to 0.02568 mu. So energy released using Einstein equation, we get energy released equals to 0.02568 into 931 mega electron volt equals to 23.91 mega electron volt. Thus, the energy released in fusion is 23.91 mega electron volt, because 1 AMU equals to 931 mega electron volt. Now, condition for fusion reaction. Usually, the lighter nuclei cannot be brought together to react because of the strong repulsive forces they experience owing to their identical nature of charge. So, the fusion process can be carried out only at extremely high temperature in order to give the nuclei of a high kinetic energy to overcome these repulsive forces. These fusion reactions taking place at a high temperature of the order of 10 to the power 7 to 10 to the power 8 degrees Celsius are called thermonuclear reaction. In order to initiate a thermonuclear reaction, temperature of the order of 10 to the power 7 degrees Celsius and intense momentary pressures are needed to cause fusion. Fusion process is utilized in the construction of hydrogen bomb. Now, release of energy. The available energy for fusion of U-35 is about 200 mega electron volt, whereas in the energy per fusion of deuterium atom is only 23.91 mega electron volt. But the mass of hydrogen atom is much less than that of uranium, and so the released per unit mass of material in fusion process is much greater than that in the fission process. Now we will see the comparison between fission and fusion. So, process fission, due to the splitting of heavy nucleus into two smaller ones. Fusion, due to fusion of the like nuclei into a single heavier nucleus. Next, condition for nuclear reaction. Fission. Neutron strikes fissionable atoms at ordinary condition. Fusion. Fusion takes place at higher temperature and pressure. Next, energy released per reaction. In fission, nearly 20 mega electron volt for uranium. For fusion, less than nearly 24 mega electron. In fission, nearly 200 mega electron volt for uranium, and for fusion, less and nearly 24 mega electron volt for deuterium fusions. Now, next, energy per unit mass. For fission, it is less, and for fusion, it is more. Now, rate of energy released. For fission, less, and for fusion, nearly 8 times more than fission. Next, material used. For fission, uranium, plutonium and thorium, and for fusion, hydrogen, deuterium, tritium and lithium. Next, ability of material. For fission, acute scarcity and expensive too. Fusion can be produced in abundance and cheap too. Next, effect of the product. Fission, radioactive wastes are harmful. Fusion, almost harmless. Next, production of radioactive isotopes. Fission, quite in good numbers. For fusion, almost nil. Next, chain reaction. Fission, chain reaction is always possible. Fusion, not necessarily. And next, peaceful use of nuclear energy. Fission, possible in controlled chain reaction. Fusion, not possible. So these are the difference between comparison between fission and fusion reaction.